In this class, let us have a look at the triggers and assertions. Triggers and assertions. And of course, in our last class, we discussed about the aggregate functions, that is a group functions with which we made use of group by clause. We made use of the group by clause and having clause. Coming to the aggregate functions, there are 5 aggregate functions. The prominent fundamental aggregate functions are sum, average, max, min, and count. These are the aggregate functions. They are also called as a multi-row functions. The aggregate functions are also called as a multi-row functions. Multi-row functions, aggregate functions. So they work on multiple rows. I want sum of all values of ratings example. So I want to find the count of values of column A. I want to know the maximum value of column A. I want to know the minimum value of the column A. So in order to have the count, max, min, sum and average, I want to find the average of column A. You can do that with the help of the aggregate functions, that is nothing but the group functions. Suppose if I want to group the rows based on one particular attribute and then I want to find the sum or average or aggregate those rows, then you can use the group by clause. I just repeat, I want to group the rows based on particular attribute. For example, there are male salespersons and female salespersons. I want the sales amounts of male salespersons. I want the sales amount of female salespersons. Means here you are grouping on the gender. All the males are being grouped and their sum. All the females are being grouped and you are finding their sum. That is nothing but you are grouping on their gender. For example, in a school environment, you are having the students of 5th class, 6th class and 7th class. I want to know the average mark of class. I want to know the average marks of 6th class and 7th class separately. Then, based on the class, you are grouping. You are grouping the rows based on class and you are giving the output. That is the aggregate function you are giving. So, average of 5th class, average of 6th class, average of 7th class. And of course, all these 5th, 6th, 7th class students are in a single database. In a single table, you are having 5th class students, 6th and 7th class students. Based on their class, you are grouping all 5th class students into one group and their average mark. 6th class into one group and their average mark. 7th class into one group and you are finding the average mark. In such case, we will be using the group by clause to group the rows on a particular attribute. We use the group by clause. Similarly, you are having the having clause. Coming to the having clause, we want to apply the condition on grouped rows. I want to apply a condition on grouped rows, not on individual rows. If you want to have a condition on individual rows, we use the where clause. I just repeat, if you want to have the condition on individual rows, we use where clause. If at all you are interested to have the condition on grouped rows, then you need to use the having clause. For example, I want to find the sum of sales amount of males and females. So males sum of sales amount and females sum of sales amount. You are grouping on male, you are grouping on gender. So males becomes one gender, females become one gender, one group, and their sum of sales amount, it is being displayed. Now my question is like this. Find the sum of sales amount gender wise only if the sum of sales amount crosses 5 lakhs. That sum should cross 5 lakhs. So male sales amount is to be summed up, female sales amount is to be summed up, and only that sales amount which crosses 5 lakhs only is to be projected. If it is not crossing 5 lakhs, you don't show. If that is the question, then we should use having. On grouped rows, if you want to apply a condition, on grouped rows, if at all you want to apply a condition, we use having clause. On grouped rows, if at all you want to apply a condition, we use the having clause. This is nothing but aggregate functions, sum, average, max, min, count, and group by to group the rows, and having clause. On grouped rows, if you want to apply a condition, we go with the having clause. This is the recap of the previous episode. Now, in this class, let us have a discussion on null values, Null values, complex integrity constraints. The outcome of today's class should be on null values. You should learn what is the null values, what is complex integrity constraints in SQL, check constraints. In many cases we use these check constraints. You should know what is meant by a check constraint, domain constraints, and distinct types, and create type, assertions, triggers, constraints versus triggers, and other uses of triggers. We need to have the discussion on all these topics, and today's outcome should be on these null values, complex integrity constraints, check constraints, create assertions, triggers. This should be the outcome of today's class. We are going to learn about these topics in today's class. Now we discuss about null values. For example, in database, I hadn't entered any value. For example, I entered student number as 101, student name is Prem, and student is studying 8th class. I entered class is 8th, and total I hadn't entered anything. I entered student number as 101. I entered name as Prem and class as 8th class. And total marks I hadn't entered anything. Not entered anything. If you don't enter anything, that is called null value. It is kept blank. It is left null. It is a null value. I am not entering anything. It doesn't mean it is 0. If I don't enter a value, it doesn't mean it is 0. It doesn't mean it is a blank space. So that is called null value. Nothing is there. 0 is a value. Here, if I don't enter anything, it is called as a null value. That is a nothing is there. In other words, we will be calling it as an unknown value. Unknown. We don't know what is that. What is that we don't know. We should not call it as a 0 value. It is unknown. So SQL provides a specific column value called as a null. You are having the concept called null in SQL to use the value unknown. This is also called as unknown value, or we call it as a null value, unknown value or null value. We can compare two null values with the help of less than symbol, greater than symbol, equal to symbol, and so on. You can just compare the null values with the relational operators less than, greater than, or equals to. And also to check the null values, we can use a reserved word called is null. Is null. There is a reserved word called is null. With the help of is null, you can check the existence of value or not there. If the value is existing or not there, you can know with the help of is null. Is null is a reserved word. Similarly, the negation of this is not null. Is not null. Is null means is it null value? Is not null. Is not null means there is some value. It implies is not null. Not null means there is some value. Is null means is it null value? That's what you can check. For example, I entered the sailor rating. I entered sailor rating as null value. Means I hadn't entered anything there. I entered sailor name, sailor number, sailor name. Sailor number as, let me say 10, sailor name as Prem, and I entered age as some 20 years, and age rating I hadn't entered anything. That is called null value. To check that, we use is null, is rating is null, where under where clause select asterisk from sailor. Select asterisk means I want complete details from sailor. Select asterisk from sailor where rating is null. Where rating is null. Where rating is null. Whose rating is null? I want the complete details of those sailors. Where rating is null means whose rating is null, whose rating is not entered. Only those tuples are being listed out. Only those records are being listed out. That is the purpose of is null. Reverse. Reverse is not null. You can observe here. Is not null means the values which are being entered, they are not null, which are being entered, they need to be listed out. So here in SQL, you're having a wonderful concept called null. If I don't know, I don't enter anything. If I don't know the value, I don't enter anything. That is called as a null value. The null value should not be considered as 0. The null value is also called as an unknown value. It is called as unknown. It is an unknown. You can compare the null values with the greater than, less than, greater than or equals to, less than or equals to symbols, relational operators. And also you're having the reserved words while comparing is null, is not null, with which you can compare the null values. So this is about the null values. Now let us move on to the next slide. It is a null is called as an unknown. Logical operators also can be applied. You can even apply logical operators with null values. AND operator, OR operator, NOT operator. You can apply AND operator, OR operator, and NOT operator for negation, not null. Is null, is not null. So in the case of nulls, you can use the negation operator, that is a NOT operator. While checking multiple conditions, when you are going with multiple condition checking, when you are going with multiple condition checking, you can make use of AND operator, OR operator, and NOT operator. It returns a Boolean value either true or false. If it is unknown, you will get U, which is an unknown value. Unknown value is nothing but null. For example, you observe this. Let us observe this. You hang AND operator, OR operator, and NOT operator. If I use true and true, it is true. Observe carefully. If I use a true and true, it is true. If I use a true and unknown, unknown means null value. True and unknown, your output is unknown. True and unknown is unknown. If you enter true and unknown, it is unknown. Unknown and true is unknown. False and unknown is false. AND operator. False and unknown is false. In this case, you observe here true and unknown is unknown. You observe in this case unknown and unknown is unknown. You observe in this case unknown and true is unknown. Unknown and true is unknown. You observe this case true or unknown is true, because in OR operator if one condition is true, the result is true. In OR operator if one condition is true, the result is true. You take this case false or unknown is unknown. False or false is false, false or true is true, false or unknown is unknown. You observe this unknown or unknown is unknown, unknown and unknown. Unknown and unknown is unknown. Unknown and unknown is unknown. So this is nothing but the null logical operators which we use with the null values. That is nothing or unknown values. This is what we do. We came to know about the null values. What are null values? If nothing is entered, that is a null value. I am proceeding to the next concept. Disallowing null values. Disallowing null values. Definitely value is to be entered. It should not be kept null. In such cases, while creating table, create table student. I am creating a table student where student number is a primary key. Primary key means it is a not null and unique. Previously I told you create table student. I want to create a table called student. Create table student. I want to create a table called student where I want to have the columns of student number, name and total. The name is not null. Name is not null means that definitely name is to be entered. You should not avoid name. Definitely name is to be entered. That is the reason I am saying student name is not null. Not null means it should not be kept null. Some value is to be entered. The total is number of 4. The total is not qualified as a not null. Hence, you may enter total or you may ignore total. Doesn't matter. But name is to be entered. Definitely the name is to be entered. Total you may enter, you may not enter. Student number is a primary key. Primary key means it is not null and unique in nature. The primary key is nothing but it is a not null and unique. Not null and unique. That is nothing but it is a primary key. So this is regarding disallowing null values. If you use not null, definitely the name needs to be entered. You can't entertain the null values. That is how we will disallow the null values. Even the primary key constraint will not allow the null values. We discussed previously, when you qualify the constraint as a primary key, the student number is a column which should be a unique value, that is a non-duplicate value, and it should not be a null value. Means definitely a value is to be entered. That is the primary key. So you came to know what is meant by a primary key, what is not null, primary key and not null. This is what you experienced. This is disallowing null values. Now, let us have the complex integrity constraints in SQL. Complex integrity constraints in SQL. Complex integrity constraints in SQL. We can specify complex integrity constraints over a single table using table constraints such as a check condition. Example, ensure the rating must be integer between 1 to 10, etc. We are going to discuss now about the check constraint. Check constraint. We examined what is a null in the previous case, in the previous example. We examined what is a null, disallowing null values. This is what we discussed. And now we'll discuss about the check constraint. I want to enter the rating which should lie in between 1 to 10. The rating which I enter should lie in between 1 to 10. So I should not enter any value above 10 or any value below 1. Then we make use of check constraint. You observe here, create table sailors. I'm creating a table called sailors. Create table sailors. I'm creating a table called sailors with sailor ID, sailor name, rating, age. Sailor ID, name, rating, age. And coming to the rating, here I'm using a check constraint. Check rating what I entered should be greater than 1 and rating should be less than 10. I'm using the check constraint check rating should be greater than or equals to 1 and rating less than or equals to 10. Whatever rating I enter into this table, sailors table, that should lie in between 1 to 10. If I enter some value like 12 or 15, it will not accept, it rejects. That is the purpose of check constraints. It checks the boundaries, and if the given value is obeying that constraint, the value is being accepted, otherwise the value is rejected. This is nothing but it is a check constraint. Ensures that the rating must be an integer and it is in the range of 1 to 10. The given rating, it ensures that the given rating is between 1 to 10. So check rating greater than 1 and rating less than 10. So the rating should be greater than 1 and compulsory it should be less than 10. It should lie in between 1 to 10. That's the meaning, for which we use a constraint called check constraint. Just a minute, you have a glance on this query, check constraint. Right, we proceed to the next query. This is on check constraints. I'm proceeding to the next one. Enforce the constraints that interlake boards cannot be reserved, etc. We discussed this. Here it is being specified about the domain constraint. A domain constraints are being specified. A domain constraint and distinct types. What is this domain and distinct? Create domain, rating val, you give any name as you wish. Create domain, I'm creating a domain. Rating val, you can give any name as you wish. You can give any name. Integer, rating val is nothing but it is an integer. If you don't enter, by default it should consider the value as 1. If you enter any value, the value will be taken. If you don't enter value, by default the value 1 is being taken. Check, the given value should be between 1 to 10. The given value should be between 1 to 10. I created one domain. Instead of number or integer, I'm saying it as a rating val. The rating value should be an integer value, and the integer value should lie in between 1 to 10. And if I don't enter anything, any value, by default it should consider 1 as a default value. That's the meaning. By default it need to consider 1 as a default value, and the given value should be lying between 1 to 10. So this range of values from 1 to 10 is given a name called as a rating val. It is being called as a rating val. Now, generally while creating a table, we say create table name, sailor ID, number of 3, rating number of 2. Instead of saying rating number of 2, I am saying rating val. What is this rating val? Rating val is nothing but it is an integer. Rating val is nothing but it is an integer. and which lies between 1 to 10. While creating table, what we do, create table, table name, create table, sailors, sailor ID is number of 3, sailor name is varchar2 of 10, rating is number of 2 or number of 3, we write. Rating is number of 2 and numeric 2 digits or numeric 3 digits, that's what we specify. But here what I am saying, rating is rate val. What is this rating val? Rating val is nothing but it is a domain of integer values, and these integer values can lie between 1 to 10. The range of integer values can lie between 1 to 10. If the given value lies in between 1 to 10, it is accepted, otherwise it is rejected. If I don't enter any value, then by default it takes 1. That is nothing but it is a domain constraint. I am creating a domain. This is called domain constraints or the domain creation. Yeah, you have a glance at this query. 1 minute, you please look at this query. Next concept. This is the creation of domains as per our interest. I can also create a type. For example, integer. Instead of integer, I want to call it as marks. Instead of integer, I want to call it as a rating type. Generally, we use integer, float, double while creating the tables. Create table, table name, sailor ID, integer. Sailor ID is an integer number. Instead of saying integer number, I can rename it and I can put some other type. So I am saying create type, rating type as integer. Means rating type is nothing but it is an integer. Now while creating table, you can say create table, table name, sailors. Sailor ID is rating type. Rating type is nothing but it is an integer. So you can have your comfort, you can have your comfortable names, identifications, comfortable names. Instead of integer, I can say rating type. So sailors rating type is nothing but integer. Create type, type name as integer or as double, as real number, as character. Right, dear students, we discuss about an assertion. Assertion is nothing but a condition we create on table or multiple tables. On multiple tables. Assertion is nothing but it is a conditions we apply on a single table or multiple tables is called as an assertion. The table constraints are associated with a single table. The table constraints are associated with a single table. SQL supports the creation of assertion. SQL supports the creation of assertions, which are the constraints associated to the multiple tables with the multiple tables. On single table, if you create, on a single table, if you create, that is called as a table constraints. But coming to the assertions, the beauty of assertions is on multiple tables you can create the conditions. You can apply conditions on the multiple tables, which is called as an assertions on the multiple tables, which is called assertions. For example, the number of sailors and number of boats put together should be less than 100. I want to have the sailors in the sailor table. That is the sailor table. The number of boats are available in the boat table. So number of sailors plus number of boats should be less than 100. Number of sailors plus number of boats should be less than 100. If either boats increased or sailors increased and if the total crosses 100, it should not accept either boats or sailors. Once again I repeat, I want to maintain the number of sailors plus number of boats should be less than 100. If at all it is crossing 100, the data should not be accepted. If I am trying to insert more sailors, it should not accept because boats are less. If I want to have more boats, if I want to insert more boats, it should not accept. If number of sailors plus number of boats crosses 100, it should not accept. It should be less than 100 only. If that is called as an assertion. I am creating a condition on multiple tables, then it is called as an assertion. A create assertion, how I am creating the assertion, you observe here, create assertion name, you can give any name. I am calling it as a small club. I am just naming it as a small club. Create assertion name, small club, check. Select count of sailor ID from sailors. Count gives number of sailors. Select count of sailor IDs from sailors plus select count of boat ID. Select count of boat ID from boats should be less than 100. Count of sailor IDs plus count of boat IDs. Select count of sailor IDs plus select count of boat IDs. So this count, sailor IDs count plus boat IDs count, should be less than 100. This is an assertion. So I created an assertion by named small club. The name small club implies the count of sailor IDs and count of boat IDs should be less than 100. It should not exceed 100. Suppose in the sailor table I am trying to insert more sailors, and sailors plus boat IDs crosses 100 limit, it will not insert the sailors. Even if I try to insert the new sailors, it will not get inserted. Similarly, if I am trying to insert new boats, it will not get inserted if the count crosses 100. This is called assertion. So assertion, there is a difference between table constraints and assertions. Table constraints are those constraints which are applied on a table. That is called table constraint. If you are applying constraints on multiple tables, then it comes to the concept of assertion. I hope the concept of assertions is clear. On multiple table condition is nothing but assertions. Now comes triggers. Triggers. The triggers are nothing but the triggering codes are nothing but they are the codes which are arranged on the tables or set of tables, and event occurs, the respective programming logic gets fired. Once again, I repeat, triggers. A trigger is nothing but a code, a triggering code, which will be waiting for an event to happen. A triggering code will be waiting for an event to happen. If that event happens, then automatically the code gets fired, that code gets activated. For example, if at all I insert student data like student number, name, mark 1, mark 2 in a student table, if at all a new student is added into the student table, automatically his results are to be calculated. Total average, his grade is to be calculated automatically. If inserted into a student table, automatically the result is to be calculated and result table should get updated. So now what happens? A code will be waiting for insertion. When you insert the student data, immediately the code gets activated. It performs calculation of total average, and the details of total average will be inserted into the result table automatically. The details of total average will be inserted automatically into the result table. That is called as a triggering code. You observe here. Let me say this is a table. This is a table. In this table, you are having employee number, name of employee, department, the department of employee, and pay, that is salary. Let me say the pay of employee is there. Let me call this table as an employee table. Now what I do is I develop a triggering code. Let me say this is a triggering code. There is some logic. I call it as a triggering code. I will attach the triggering code to this particular table. To this particular table, I attach the triggering code. Whenever a new employee gets entered, automatically this code should get activated, it should get fired, and it should insert his HRA, DAs, tax and other details into the pay table. Let me say into the scale table. Let me say the name of this table is called scale table. Into the scale table, the data is to be inserted. Whenever you insert into the employee table, automatically the data is being processed, and the results are being stored in another table called as a scale table. Then this is called as a triggering code. The triggering code will be waiting for an event. The event is nothing but insertion. Sometimes I will say delete. Whenever we delete, the data is to be stored. The deleted data is to be stored in another table. You delete the data from this table and automatically store in a backup table, if I say. So deleting is an event, insertion is an event, updation is an event. So we will be waiting for an event to occur. Whenever that event occurs, the respective logic gets activated. So this is nothing but it is a trigger. The triggers are generally designed by DBA, that is a database administrator, and DBA arranges these triggers on the databases, that is the tables. They get activated. So in trigger you are having an event. There will be three parts: event, condition and action. For example, when inserted, So the event is insertion. When inserted, if pay is more than 50,000, that is a condition. If when inserted, that is rather insert is an event. If the employee's pay is more than 50,000, that is a condition. Then only this logic should get activated and it should store the details in the scale table. So that is nothing but action. Storing into a scale table is nothing but an action. I just repeat. Generally the triggering code contains three parts. One is event, second is condition, and third is action. Event, condition, action. Coming to the event, when inserted data into this table, so insert is an event. And in the inserted data, if the pay is greater than 50,000, that is a condition, greater than 50,000, then the logic should get activated. It should calculate HRA, DA, tax, etc., etc. It should store in scale table. That is nothing but action. So the trigger contains event, condition, and action. Event, condition, and action. These are the parts of a trigger. Trigger generally, the event will be insert event when inserted, or when deleted, or when updated. It is a daemon which will be continuously looking, monitoring. It will be monitoring the tables for events to happen. When insert event happens, when delete event happens, when update event happens, automatically the trigger gets activated. Gets activated, and the results you get. When you go with the update event, suppose one employee's salary is 20,000. The salary of one employee is 20,000. Let us think so. The salary of employee is 20,000. Now I am updating. The 20,000 I want to update it to 25,000. Then the 20,000 is called old value and this 25,000 is called new value. When there is a case of updation, especially updation case, you will get the concepts, reserve words. We will be using some reserve words called old and new. We use certain reserve words called old, new. Old is nothing but the existing value, new is nothing but the latest value. For example, an employee is having a salary of 20,000. The 20,000 is already there. Now I want to modify it to 25,000. Now the existing value is called old value and the 25,000 which I want to update, this is called as a new value, old value and new value. So with this we will be activating the triggers. Certain program logics gets activated and it performs certain modifications, updations, deletions and DDL commands. Sometimes data definition commands, that is the DDL, data definition language commands, like creating tables, changing authorizations, deleting the tables and all that stuff, altering the tables, all that stuff can be done with the help of triggers. So in total you need to understand a triggering is a programming code which will be waiting for an event to happen conditionally. When that event happens, the triggering code gets filed and takes necessary action. That is called as a trigger. In trigger, you are having something like a before triggers and after triggers. Before triggers and after triggers. Of course, all this will be demonstrated practically in your laboratory session. In your laboratory sessions, all this will be practically demonstrated. Before inserting, so create trigger name. You can give any trigger name. Before insert, you observe here, before inserting on student into the student table, before inserting, I am using count equals to 0. Before inserting, I initialized count equals to 0. The value of variable count will be 0 before inserting. After insert, coming to the after insert, create trigger name after insert. Here I am using after insert. Here there is a before. Here I am using after insert. After insert, I am using some logic here. You observe here. Count equals to count plus 1. After insert, the count should be increased by 1. In the beginning, before insert, in the beginning, the count is 0. After insert, the count got increased by 1. Count equals to count plus 1. This is called as a triggering code. Of course, we study this triggering code in detail and we do practically in the laboratory sessions. For time being, you remember this is a trigger which gets activated before insert. This is the trigger which gets activated. This logic gets activated after insertion, before insertion and after insertion. These are nothing but the triggering codes. And of course, the triggering codes just resembles the constraints. They just constraint, they resemble the constraints. Designing the active databases. Whenever the triggering code gets activated, multiple tables gets activated, multiple tables internally gets fired, and sometimes we feel difficulty to trace out the actions what are being taken by trigger. I'll write a code to insert some data in A. I'll write a triggering code to insert data in B. I'll write a triggering code to delete data from C. So one trigger can take action on multiple tables. So if a trigger gets activated, it is difficult for us to trace out the actions happened by that trigger. What actions happened by that particular trigger? So triggers are a bit difficult when compared with the constraints. The constraints versus triggers. The constraints are simple, which can be applied on a single table. That is a constraint. Triggers are those which we write as per our requirement, we tailor the programming code as per our need, and the triggers can be arranged on single table or multiple tables. So that is a difference between the constraints and triggers. Constraints are simple. They will be generally used on single table. Triggers are the programming code we need to write. Similar to C programming, we need to write a programming code. And these programming codes coming to this programming code that gets activated conditionally on either single table or multiple tables. The triggering programming code can get activated on single table or multiple tables. So they are tailored, they can be designed as per our requirement, which is called as triggering code. So that is the difference between the triggering code, that is the difference between the triggering and constraints. Constraints on single table, they are simple to understand. Triggers can be arranged on single table or multiple tables conditionally as per our requirements you can design. The other uses of triggers, coming to the uses of triggers, they are unusual events. If any unusual events happens, triggering code can alert you. Suppose in a banking system, the banking hours are from morning 10 o'clock to evening 5 o'clock. In a banking system, banking hours are from morning 10 o'clock to evening 5 o'clock. Suppose if some person want to insert at night 10 o'clock some data into the database system, then automatically the trigger gets fired, activated, and it alarms. You can develop a code in such a fashion that out of this banking time, if anyone wants to touch the computer or if you touches the database, automatically the trigger should get activated. It should alarm you. You can do that. So unusual events, to track the unusual events, you can create triggers. Similarly, log of events. If you want to create a log of events, I am doing some actions, some events on my systems. Every event is to be recorded. A log file is to be maintained. Every event of mine, every activity of mine is to be recorded into the database. Then a log of events are to be maintained. Yes, you can do with the help of triggers. And if at all you want to have some security checks, with the help of triggers you can do. Some statistics on the table. If I want to know the statistics on table, yes, you can do that with the help of a trigger. And the workflow management and enforcing business rules. So first activity, second activity, third activity, fourth activity. There will be some stages of activities. If I want to record the stages of activity, that is nothing but workflow activities. The first activity, second activity, third activity, and so on. That is a workflow activity. If at all I want to follow the workflow activities stipulously, then also we can make use of triggers and see that everything happens correctly. So these are nothing but the triggers, and of course we discuss about these triggers practically in our laboratory sessions. Dear students, in this class, the outcomes of today's class, the learnings of today's class, it should be on the integrity constraints of SQL, check constraints, and we came to know about the create type. You can create your own data types, create types, assertions, and triggers. So constraints, assertions, triggers, and check constraints. This is what we discussed in this class. Have a wonderful day. Thank you.